Welcome to a new deep dive, The Learner. Today, we're digging into something pretty interesting in the LLM space, React prompting.
Yeah, it's a really neat engineering approach.
Yeah.
Typically language models just generate text based on patterns they've seen,
Right.
but React adds another layer. It's like giving the model a way to think and then actually do things using external tools.
Okay. Thinking and doing. So, not just talking, but taking action based on some kind of reasoning. Let's unpack that.
Exactly. We're giving it sort of an internal monologue coupled with the ability to interact, like using a search engine or running some code.
So, we're going to look at how this whole reason and act thing actually works under the hood and, well, why it's a big deal.
Yeah, our mission today is basically to lay out that core loop, the reasoning and acting part. And we'll look at what kinds of tasks this is really good for. You'll probably see it mirrors how, we often solve problems ourselves.
Okay, so let's start there. What exactly is React prompting? Lay it out for us.
So REACT, it stands for Reason and Act. And it's basically a strategy for prompting, for instructing these models. It encourages the model to, first, verbalize its reasoning process, like thinking step by step in plain language.
Okay, think first.
Right. And then based on that thinking, it uses external tools, maybe a search engine, maybe a calculator. Could be anything really to find information or perform an action.
Gotcha. So it's this mix of internal thought and external action.
Exactly. And it allows the model to handle much more complex stuff through this sort of back and forth process, iteration.
So it's not just one shot, generate the answer.
Yeah.
It's thinking, doing, checking. Can you walk us through that cycle, this thought action loop?
Yeah, absolutely. Think about how you'd solve, I don't know, a complex research question. You'd think about what you need, maybe look something up, see what you find, and then decide the next step, right?
Sure.
React is kind of like that. The LLM gets the initial prompt, the task. First, it reasons,
Yeah.
generates some text explaining its understanding of the problem and maybe its initial thoughts on how to approach it.
Okay, so step one is just thinking about the problem itself. Makes sense. Then what?
Based on that reasoning, it forms a plan. It decides what specific action it needs to take next. And crucially, this action usually involves calling an external tool.
An action involving a tool. Like what kind of action?
Well, sticking with the research idea, the reasoning might be, I need to know the population of London. The action would then be formulated as, say, using a search tool with the query population of London.
Right, so it thinks, I need this info, then it acts by searching for it. What happens when the search results come back?
That's the next key part, observation. The LLM takes the output from the tool, the search results, the calculator output, whatever it was, and incorporates that as an observation.
So it sees what happened when it took the action.
Precisely. And that observation isn't the end point. It feeds directly back into the model's context.
Ah, okay. So the new information changes its thinking.
Exactly. It uses this new observation to refine its reasoning. Maybe the first search wasn't specific enough, or maybe it answers part of the question, and now it needs to figure out the next part.
Yeah.
So it thinks again, plans another action, acts, observes,
And it just keeps looping like that. Think, act, observe, think, act, observe.
until it reaches a point where its reasoning concludes it has the final answer to the original prompt.
Wow, okay. That sounds way more dynamic. It's like it's actively working the problem.
It really is. It allows the model to tackle things that need multiple steps or information that wasn't in its original training data because it can go get current information. It grounds the model's responses in, well, potentially more up-to-date reality.
This really helps clarify it. Could we maybe walk through a concrete example, make it even clearer?
Sure. Let's use that Metallica example you mentioned.
Yep.
The question is, how many children have a famous dad that performs in the band Metallica?
Okay. A standard LLM might guess, or pull old data. How to React tackle it.
Right. So using React, probably with a search tool connected, the model would start reasoning. Something like, okay, the question is about the total number of children of Metallica members. First, I need to know who the members are. I know Metallica has 4 members, so I need to find the number of children for each member and sum them up.
Makes sense. Break it down.
So the first action might be, use search tool with query, how many kids does James Hetfield have?
Okay, it searches.
Then it gets the observation back. Let's say the search returns. James Hetfield has 3 children.
Got it. One down.
Exactly. The LLM takes that observation. Its next thought might be, okay, 1 of 4 members checked. James Hetfield has 3 children. Now I need to check Lars Ulrich.
And it just repeats the process?
Pretty much action. Search, how many kids does Lars Ulrich have? Observation. Let's say 3 children. Thought, okay, 2 of 4 members. Total children so far. 3 plus 3 equals 6. Next is Kirk Hammett.
And so on for Kirk Hammett and Robert Trujillo.
Yep. Search for Kirk gets maybe 2 sons. Search for Robert gets 2 children. Each time, it observes the result, updates its internal count in the thought step until it's checked all 4. The final thought process might look something like, okay, checked all 4 members. James Hetfield, 3, plus Lars Ulrich, 3, plus Kirk Hammett, 2, plus Robert Trujillo, 2, equals 10 children in total. The final answer is 10.
That's a brilliant illustration. It really shows the step-by-step nature, using the tool, observing, and then reasoning towards the final answer. Not just a guess, but a procedure.
Exactly. It methodically gathers the pieces it needs using the tools available. That's the power for these kinds of questions that require, pulling together different bits of information.
So thinking about this from an engineering standpoint, where does this REACT approach really make the most sense? What are the ideal use cases?
Well, it shines anywhere you have tasks that aren't just simple Q&A, things that need multiple steps or require interaction with the outside world for, like, current data.
So complex queries, maybe?
Definitely complex queries like the Metallica one. Also things like planning if you need to interact with calendars or booking systems, or tasks requiring up-to-the-minute information, like checking stock prices or news summaries.
What about interacting with code or APIs?
Oh, absolutely. Imagine asking it to fetch data from an API, then maybe perform some calculations on that data using a code interpreter tool, and then summarize the result. REACT is perfect for orchestrating that kind of multi-tool workflow.
So anywhere the model needs to go beyond its static knowledge base and actually interact or investigate?
Precisely. It's for building more capable agents, essentially. LLM applications that can tackle more sophisticated real-world tasks by combining that language understanding with the ability to take concrete actions.
Okay, this has been super insightful as we kind of wrap up our deep dive on REACT prompting.
Yeah, you can really see, I think, that REACT is more than just a prompting trick. It's a significant step in how we engineer capabilities with these large language models.
Right. It's about enabling them to not just talk, but to reason and interact using tools. It unlocks a whole new set of possibilities.
Absolutely. That reason and act loop, that cycle, is the heart of it. It lets the models explore, learn from interaction, iterate. Much like we do when we face a complex problem, right? We think, we try something, we see what happens, we adjust.
It definitely mirrors that human problem-solving process in an interesting way, giving the AI a way to, well, figure things out more actively.
Exactly. We hope this discussion has given you, the learner, a clearer picture of what REACT prompting is all about and why it's such an exciting area in AI engineering right now.
Thanks so much for joining us on this exploration. If you found this useful and want to keep up with the latest in AI, definitely hit subscribe for more deep dives like this one.